So we're back with our fifth episode of the Utility Strategy Podcast, the first infrastructure podcast to shine a light on what we love to call utility strategy. As we all know, buried utilities pose an enormous risk to any infrastructure project, often causing schedule overruns, unexpected costs, and of course, utility strikes. But with the right utility strategy, we're able to mitigate that risk and streamline our project. And that's what our podcast is all about. Sharing and gaining all kinds of insights that will enable just that. Helping project managers, utility coordinators, estimators, mappers, planners, designers, engineers, and any other stakeholders overcome the challenges of buried utilities in our right of way. To help us do just that, we have here with us today Gary Huffman, who's going to talk to us about smart grids, undergrounding, and everything in between. So a bit about Gary. Gary, with all his 30 plus years of experience in electrical, water, and gas utility design, is a senior client relations manager at Burns McDonnell at their transmission and distribution group. Since joining Burns McDonnell, Gary has served as a project manager of a 600 million transmission infrastructure program and has used his experience to create the company's grid modernization program. Outside of the company, Gary is involved in countless industry-related organizations, helping to bring order to this chaotic but amazing industry that we are a part of. So Gary, how are you doing today?
I'm great, David. Thanks for having me today. I'm looking forward to the conversation.
Give us a little background of what's happening now in the industry. Everyone's talking about DER. What's happening here? Tell us a bit about it.
Well, clearly, climate change and other factors, including customer expectations and financing capabilities, have put us in a situation, at least here in the U.S., where we would like to retire traditional generation assets, coal, gas, and honestly, the fleet was getting old anyway. And so, as part of the new strategy for generation, for providing power to consumers, we're looking to newer renewable type of sources of energy to solve a lot of problems, not just the aging problem, like I said, but perhaps some climate change problems as well. And so solar, rooftop solar, utility scale solar, wind, same thing, utility scale wind, hydrogen, other types of generation resources are really driving this, what I would call a once in a lifetime change in our industry towards these renewables.
And Gary, sorry, just for the layman, could you just go over the acronym DER? Because not everyone is a part of our industry. Yeah.
I think that is a great point. DER, distributed energy resources. The word distributed coming from the fact that traditionally you had one big power plant, and now we're looking at replacing that one large facility with distributed facilities, rooftop solar, local battery storage, energy efficiency in a school district or neighborhood. And so that's where the word distributed comes from. So you end up with distributed energy resources. It does include some unique types of energy strategies, such as demand response, for example. Demand response is when energy consumption is high on a very hot day, let's say, and we're having trouble meeting all the load. We can all turn off our air conditioning, or we can not do the laundry to reduce the consumption during specific time periods to reduce the overall peak demand. And so the ability of distributed energy resources, one of the good things about it is it gets it very close to where the load is, right? If you have load at your house, you're charging your EV, let's say you're into all that, or turning on the lights when everybody comes home, cooking dinner. Well, it's nice to have had maybe solar on your rooftop that day and a little battery in your garage, to provide you the power. You're not dependent on some power plant that's maybe 1,000 miles away or 500 miles away or someone else. So.
Gary, I've actually been looking at one of the examples you gave, hydrogen, which is really funny. A friend of mine just bought a hydrogen vehicle, and he was showing me a map of where he could actually fill it up, and it was California and Vancouver. So, or in BC and Vancouver. So just two cities or just two areas where he could use this car. I think he showed me one hydrogen station in Texas. So I just found it very, very interesting that it's very localized. Do you find that the sector of DER is also very localized into certain areas, or is it something that's really catching right across the U.S. right now?
No, I do believe that electrification of the transportation fleet. So whether that's your personal vehicle, Ophir, or that's, let's say a fleet of school buses or a fleet of forklifts in an Amazon warehouse, right? I do believe that we're getting very unique cases on the electric vehicle side. And we've actually seen in the United States a large commitment from car developers to transition their manufacturing facilities to electric vehicles. And so that begs the question, how are we going to charge these vehicles at least in the near future? I think it's a simple problem if we had lots of time, 20 or 30 years to solve it. But we don't have that time. We've got 3 to 5 to 7 years to solve those types of problems. And so we're seeing some really unique regulation, which we'll talk about it a little bit. We're also seeing technology companies step up to the forefront with their charging strategies. And then if you take a vehicle like Tesla, the Tesla charging algorithm, when you get into your Tesla in the morning, it'll tell you all the different places where you can charge your vehicle that day. And so those types of assistance will be great in the future. Hydrogen is a bit of a unique case. It is out there several years before we figure hydrogen out. Although I do remember, Arnold Schwarzenegger had a hydrogen car when he was governor of California, and he did have his own personal charging station at LAX.
Was that his hydrogen Hummer? No, I think that was a standard diesel Hummer which he had. But
yeah, right. But I do believe as we figure out hydrogen, it'll follow a similar technology path. That the charging, the recharging will become available fairly frequently. I just did fly into Columbus, Ohio, and they've transitioned the rental car buses and all the shuttles serving the airport to electric vehicles. Wow. And I'll tell you, it's a nice, smooth ride. And of course, Columbus was designated as one of America's smart cities a few years ago. And so, I thought I was very impressed. You couldn't hear anything running. It was nice and quiet. So the air pollution, the noise pollution was down. Obviously, the emissions was down. So it was a great experience, actually. So,
how do you see yourself, especially at Burns McDonnell? You guys really have a large focus on renewables, correct? Just in terms of your business and what you're doing.
We do. We have, and we do it from several angles, Ophir. One is on the utility side. Our utility clients are expected to kind of provide some of this infrastructure. So I'll call that the supply side. So we work with our utility clients on the supply side. We have a very robust EV, electric vehicle design team that works with our electric clients. On the demand side, we also have a robust business going, and it's just growing and growing. It's similar to cybersecurity, right? There's really no end in sight. If I was a kid in high school and I was thinking about what kind of college degree would I want, I'd be going for, electric infrastructure or cybersecurity. Those things are going to be around for a long time. So,
but not civil engineering.
No,
that's my first.
Yeah, civil engineering is a valuable, it's a valuable tool, right? We could not do any of our businesses without our civil engineering team. So I no intention on disparaging our civil friends out there from the American Association of Civil
Gary,
Engineers. So I have a lot of good
American
buddies.
Society of ASC, American Society of Civil Engineers.
Gary, talk to us
Yeah.
a bit about what's happening in the regulatory standpoint of DER. What's happening there? What's new?
Well, on the regulatory side, um, it varies. Okay, so if we take in the U.S. at the national level, so transmission, for example, is regulated by the Federal Energy Regulatory Commission, the FERC. It's a government entity, and they've done quite a few things to facilitate. I'm going to say facilitate DER adoption, and really that's the most important role of regulators, is to make sure that the markets help the markets work and facilitate the decision making of decision makers, right? And so FERC recently, for example, issued Rule 2222, which allows a DER penetration. It allows for DER all the way down to 10 megawatts at the distribution system to bid back into the transmission marketplace, so that they could get fair prices for their resources, right? And it doesn't allow the utilities, at least all utilities, to exclude that DER participation. So the most important thing the regulators are doing lately is to facilitate the marketplace, to stimulate market entry, to reduce the barriers to market entry. You don't have to have $1 billion to invest now to build a power plant. You can build a 10 megawatt or a 50 megawatt power plant for a few $1,000,000 and participate in the DER marketplace. I think that's going to drive innovation. It's going to stimulate that section of the economy as entrepreneurs, capital investors, other types of folks all come together to figure out how can they best create the market. And then when it comes to actually regulating that market, I think that's a little bit further down the road as we get more and more participants and it gets a little more complicated. Then we'll see more market rules. At the state level, the electrical distribution systems in the United States are all managed at the state level, and the states are very diverse, right? What they're doing in Hawaii, California, Massachusetts is not what they're doing in Florida, Georgia, Texas, right? Very different. And so one of the challenges in our business is making sure that our regional offices understand the regulations and that their clients are exposed to in Colorado, in Arizona, in New York, right? And that's one of the roles I help play here. Is I help our engineers and our project managers understand what type of business stresses their clients are under. It does create opportunities. Most investor-owned utilities, of course, are monopolies. About half the distribution load in the United States is served by large investor-owned utilities that are, Fortune 500 companies.
Yeah.
The other half of the load is served by municipalities and co-ops. And so it depends really where the load center is. So it could be a small city that's running their own electric grid, and maybe they want their school buses in their city to be electric, and so they pass legislation locally to do that. Or it may be, a larger state like Ohio that decides that we're going to incentivize our utilities in investing in DER and other smart city type things. And we're going to let them recover the cost of that in their rates, so to customers.
Gary, with all this, with the different regulations right through and through, and the true difference, what do you think the difference would be on the actual grid if we start doing all these small installations? Do we think that there's going to be a lot more construction? It's going to be a temporary thing. It's going to be a permanent thing. Like, do we really see this as that next step in terms of energy, our energy use, and the way we're actually accustomed to doing the standard builds?
So the current design of the system at the transmission level, with the exception of transmission location and corridors, you could do a lot. It's a very diverse system. Power can flow both directions. You can attach to it at many different locations to provide generation. All the rebuilds of the current transmission system are based upon, well, we had a transmission line that ran out to Wyoming for a coal plant. Now we need to relocate that transmission line 100 miles south in Wyoming to where the wind farm is. So at the transmission level, I think we're in pretty good shape. There are discussions, technical discussions about power flow and reliability and resiliency, which we'll get to later. On the distribution system, it's a much more complicated problem. The distribution system was built least cost, in the 50s and 60s and 70s, right?
Yeah.
And a lot of the distribution lines are lateral, meaning that they go out to wherever the load is. The one line goes out to the little farm town and serves that farm town, and there's not redundancy or resiliency. And if you put DER, if you put battery storage or solar on all the roofs in that little farm town, it's not really well positioned to feed that power back to someplace else. And so two-way power flow, the capacity of the lines, voltage constraints, there's a lot of technical factors that we need to consider when we're allowing this DER to attach to the system.
I'm going to ask you. I'm going to ask you a really interesting.
Yeah.
I'm going to ask you a really interesting question tied into this, actually. So, with the current electrical system, I know that there's a lot of operators, with mergers and acquisitions and large purchases and mergers and demergers and so on and so forth, that a lot of operators don't actually have a handle of their actual assets. By actually bringing in DER, would that make it easier to control the assets in terms of what we have, in terms of where it is, or is that just adding on to the pile of different items which we don't, just adding on to the pile of information that we require to manage?
Well, it does create a situation, Alfir, where in the past the utility, they owned and operated everything, and they worked with their state regulator, for example, to meet the needs of their consumers, of their customers, right? And now that we're opening the marketplace to third-party DER owners, as well, we're opening the marketplace to aggregators who can go get 100 customers and say, let's all sign up for energy efficiency together, and they manage that energy efficiency program. So it does create a more complex control system as these additional business partners come in and participate in the marketplace. And so the marketplace will be much more sophisticated than it has been in the past. There will be more room for error, but there is also more room for opportunity. And so I look at it as a positive. We're looking forward to more people participating in the market, letting that entrepreneurship, letting that innovation take over and help us solve some of the technical problems.
In terms of DER installation, do you think most of it would be underground, or would it be in the traditional above ground, pole to pole? Or are they actually looking at the future and saying, wait a minute, let's take lessons learned from the past? And I know that we have a big push for undergrounding as well, but these installations which we're talking about, are we talking about just putting up and connecting to the existing wiring, or the existing three-phase and so on and so forth? Or are we actually talking about an innovation and also a renewal, per se, of taking that new source of energy and actually doing it right and tying it in and actually burying it versus just tying it into the existing above ground pole lines?
Yeah, I think that's a great question, Ophir. And undergrounding is certainly something that the perception of undergrounding has definitely changed. In the past, overhead was just much less expensive, but we didn't see all the other benefits that we now recognize undergrounding has. Honestly. So, to my previous point on regulation, I think everyone's looking at it slightly differently. but I'm a big advocate for underground. At Burns McDonnell, we think undergrounding is the future and of the utility space. And so we have a very robust business helping our clients make those types of decisions you just talked about. If you're going to have battery storage and that's designed to meet the energy needs of clients during a hurricane or during a severe ice storm or during a fire, well, you can't necessarily rely on traditional overhead line construction to support getting that energy distributed where it needs to be. So you really do need to look at undergrounding in that case specifically as probably part of the resiliency package that you put together. So yeah,
Part and parcel, understanding how important resiliency is, and really understanding where things are. How do you guys actually account for what's already in the ground? Because there's so much in there. What do you do? What steps do you do to mitigate the risk of how you design and how you build efficiently? Because as we know, there is a lot of infrastructure in the ground already. What type of steps are you taking, Gary, or your company is taking to actually account for this?
yeah, this is this is an important topic because undergrounding has a lot more, well, not a lot more, but it's some significant. If you don't know where the asset is, and you start digging to do new stuff, you can run into problems very quick. And unfortunately, that it's from my perspective, having managed construction crews as well as engineers, it can be dangerous if you don't know where the existing facilities are. And but with that being said, the modern tools that we have today are critical parts of the process now. For example, the GIS system, most everybody in my industry understands that you need to GIS locate, all of your assets, whether they're overhead or underground. And when you do it underground, you need to be very precise, not only about the latitude, longitude of an asset, but also the depth that it is under the ground. And then when people are building, and they call in for a locate. A locate is when someone new comes in and they want to do some new infrastructure. They say, "Hey, I want to dig over here. I need to dig a trench for a new sewer line." Our utility clients will go out and help them, and they'll mark the existing underground electrical infrastructure and water infrastructure and say, "Well, you can't dig here." And the way we used to do it, honestly, is we'd all meet out there, and everybody would have their maps, and it would be a little frightening because some of the maps would be 10 or 20 years old, and maybe the guy had been with the company a couple of years, so he didn't have all the tribal knowledge, well,
Yeah.
no. Now, sometimes it worked out because you'd get the guy, well, I actually was here when they built that 30 years ago, and it's right here. And, but, as we get baby boomers retiring, as we get a
Yeah.
turnover, we need these tools for this to be successful, and not just from an efficiency and a resiliency perspective, but from a safety perspective as well. So, yeah.
So what I understand from you is you're saying that a lot of the knowledge is getting lost right now because of the digitization and because of our modern world. That they're getting not pushed out, but they're retiring right now, and with that, a lot of knowledge is being lost, and it's not being captured in the digital form. Now, when you actually said something which really interested me, you said you rely based on GIS, and the funny thing with that is, it can make a great picture. Digitalization and visualization is great, but the question is, how accurate is it? What is its validity? What is its pedigree? And these are the things I always get into because I come from the underground sector, and it's really, who actually drew this and how did they get that information? How did they actually convey it? It looks great on the database, but is it actually true? Above ground, you can verify with your eyes. Below ground, that's a whole other ball of wax. And just to convey right through and through that there's been an industry which has been dedicated to that, and that's the SUE industry, Subsurface Utility Engineering Industry, and ASE, the American Society of Civil Engineers, along with its newly created institute, Utility Engineering Survey Institute, which, by the way, this is its lovely pin. It has really focused on creating standards for the interaction of existing and new infrastructure and now as-built infrastructure. So really, when we're talking about underground, we're talking about the interaction of the infrastructure. There's the ASC 38 standard, which is the standard of investigating or depiction of existing infrastructure, and there's soon to be an ASC 75, which is going to be the as-built standard, or the as conveyed constructed standard, or documentation, dedicated documentation and conveyance of existing information and sharing of that information. So it's really interesting, what you said right now, that with the locate process, because the locate in truth is only for that construction period. When you call in for a locate, it's only right before you're about to dig. And looking back at the SUE industry, and that's the subsurface engineering industry, how it's evolved, and the need for information has really gone forward. That is a key point, which I see all of us in the industry, you from the above ground side and the underground side, and especially the renewable side, where we have an opportunity to really work together to get things up front and right, and then really follow the standards. And talking about standards, Gary, what have you seen your industry, all the different ASTM standards and so on and so forth? Have you seen any? Have they been keeping up with the new innovations of DER?
Yeah, that's a great question, and I do agree with you that I'm optimistic about the underground. Just to finish that topic on the underground locate, I'm very optimistic about the future there. Some of the standards that are coming out, and some of the best practices that I see. For example, when you do put something underground and you do take the time to make sure you locate it accurately on your digital tools, you can also do things like put an RFID tag on it, right? An RFID tag is a tag that helps you find it later, right? And I also see standards like, well, if we don't have the benefit of knowing exactly where it is, we caution the construction company, okay, we're going to mark it right here, but we recommend you hand dig, 2 feet on each side of it, because it's not going to, we don't know exactly where it is. And so hand digging might prevent you from, using a backhoe or some other big tool and causing some type of catastrophic failure. With respect to new things that some of the industry bodies are doing, I chair the IEEE Distribution Resiliency Working Group. That resiliency working group is coming out of a lot of utilities that are saying that we want to actually measure our resiliency of our system. And so we're looking at metrics that would work very similar in the United States to IEEE 1366, which is the reliability metrics. So SAIDI, SAFE, MAFE, and
a whole bunch of other acronyms, yeah.
Yeah, not to get in acronym soup, but on the reliability side, we want to know how many outages do customers suffer. How long are those average durations of those outages, and we measure our system performance based upon those metrics. We're looking at coming up with similar metrics for resiliency. When the hurricane came, how well did the system withstand the hurricane? What was your operational awareness, and what did you do to prepare? And then how quickly could you recover afterwards? And so those types of metrics, and a lot on the regulatory side, a lot of states are really interested in measuring utilities against this with a performance-based rate making schedule, where hey, you're a monopoly, you don't have to compete with people. But in order to make your profits, then you have to have good performance, right? And that performance is based on your reliability and your resiliency and how well you do. And the way I like to say it, everybody wants the Amazon experience these days for everything, right? When they drive through for food, when they talk to their utility company, they all just want this easy, no hassle, quick. Here's the cost. Get it at your doorstep, fairly quickly, right? So a lot of customer expectations and customer service are going up, and so we need to figure out how, as an industry, can we meet those expectations, those customer expectations. Um, so on the standard side, we're looking at that. We're also looking at standards when it comes to this some of this DER. A lot of states have said, hey, the DER needs to be as reliable as a basic power plant used to be, and how do we do that? And so we need new tools on the system like voltage regulators, inverters, other solid state devices with smart algorithms, so we can help manage that DER and make sure it's going to be there, when we need it. So.
That's very
Which
interesting.
states, Gary, are you seeing taking action regarding resilience of the grid?
So, for example, you're probably all familiar with the wildfires out west. Obviously, states like California, Colorado, Wyoming, Washington, Oregon, they're all very interested in understanding the resiliency, the benefits that they would get, from fire hardening, right? In the South and on the East Coast of the United States, um, you see a lot of storm hardening. A lot of resiliency efforts these days are going to be couched as what we call storm hardening, right? Riding through the storm. So, for example, utilities in the South, they used to do wind loading of their poles to 60, 65 miles an hour. Now they're using wind loading calculations of 165 miles per hour, right?
Yeah.
And so all of a sudden, a wood pole is not
Not
going to
good
work
enough.
out for you as an engineer.
Yeah.
You need a concrete pole, you need a steel pole, right? You need much more robust hardware. And so the analysis tools enable us as engineers to help our clients decide which parts of resiliency that will benefit on the design side. And so to answer your question, David, I think all states are interested in resiliency. Uh, with what's happened in Texas the last couple of years,
Yeah.
a couple of devastating hurricanes in southeast Texas, and then the freezing in Texas, which resulted in a gas outage. Uh, Certainly, their regulators and their consumers are demanding a more resilient, more robust
I'm
system.
thinking
So.
about
What about what about the adoption technology? Like, how do you actually innovate and actually encourage the adoption of new technology within those systems? It's really, it goes part and parcel that innovation needs a push, and that push is normally technology. So how are they actually taking that and adopting the new technologies? For example, on our side, the underground infrastructure side, I see them actually trying to look at more information up front during their planning phases, so they understand what's going on, and adopting a lot of different technologies within it. And what do you say is the DER, or in general in the electrical distribution transmission side of their adoption of new technology?
Well, I think that's a great question because honestly, in the past, there was never utilities don't get reimbursement for research and development money, right?
Yeah.
They don't have R&D funds. They're not like the national labs or the universities that use Department of Energy money or other money or private capital to invest. And so, in the last decade, we've seen more and more states adopt some small amount of money in just a handful of million. Like in California, I think it's $10 million over 2 years. And what they allow the utilities to do is to adopt some of this emerging technology in the form of pilot projects. And those pilot projects, uh, they'll let them try several samples of it. And if they can make a business case that, well, this technology benefits customers in general, then they're allowed to, seek recovery for larger investments. So I'm excited that most states now have a small recovery mechanism for technology adoption. Interestingly, in Hawaii, they want to get to 100% renewable by 2035.
wow.
They're looking at how to do that. Um, when they required the Honolulu Electric and the other utilities to submit a strategy to get there, they said, well, what we don't want to do is we don't want to pick technology now and crowd out future technological benefits. So instead of giving us we do want to see your plan to get there eventually, but we really want to do it in 3 to 5 year planning segments. That way, we're not putting all our eggs in one basket on one technology. And if there are benefits in technology, we'll be able to take advantage of them in the next 3 or 5 year period and in the next 3 or 5 year period. So with the adoption of some research and development type pilot programs, and with this regulatory strategy of let's do it in shorter incremental planning sessions, I think that helps pace the technology adoption, Ophir, at a good rate. Now, technology moves very fast, right? And regulation intentionally does not move very fast, right? And so you will have this yin and yang, right, conflict between technology adoption and regulatory guidance, because they're just very different processes. And honestly, we want technology to move fast, and we're excited that it moves fast, but we also want regulation to move fairly methodically, deliberately, slowly, so we don't get in regulatory situations where, like when we deregulated the energy markets before, we had this Enron situation, right? Where electric companies couldn't even buy power, they couldn't afford to buy power in California, and the state had to step in and all those sorts of things. So I applaud the fact that the regulators are being methodical, but yet they're providing these small opportunities for technology adoption. And in the standards community, as you know, Ophir, right? You don't want to push out a standard overnight. You want to get consensus in the professional community. I chair several committees. I chair the IEEE Resiliency Committee. We don't want to come out with a metric with just a handful of people who are screaming the loudest, saying this is what we need to do. We want to build consensus across the technical community, across the business community, and make sure whatever standard guidance we provide is widely accepted and has been thoroughly vetted by the industry. So
one of the analogies I've always seen, I've always said standards versus innovation. The innovation is that little dinghy, a little dinghy boat which can turn on a dime and really maneuver. And standards are always like a cruise ship, where it's going to get to its direction, it's going to go to where it's going, but it takes a long time for it to turn. It takes a long time for it to stop. So it's absolutely amazing how things are so parallel in the underground and in the above ground, and just in general. Innovation is always going to be pushing the regulation, and regulation is always going to be that steady as she goes course. So sorry, my little observation on that.
Regarding regulation, and you know what? Not only regulation, but we're going to see with the emergence of DER, we're going to see lots of new utility owners that will probably go into undergrounding. So we're going to see lots of new utilities put in the ground. And I'm kind of wondering, how are all these new actors going to handle this this issue? Because there's going to be a lot of utility owners crossing each other. So how do you think that's going to happen? How do you think that's going to work with each other?
Yeah, it's a constant challenge. In older communities, and we have some examples right in Europe, right? I mean, they're on version 25 of infrastructure, right? I mean, they've been building over building over building over building. In the United States, we're actually blessed that we only have a few communities: Philadelphia, New York City, some of the older East Coast cities where we're on maybe the third or fourth infrastructure renewal cycle, right? Although our engineers do still find underground cables in vaults in New York City that are stamped with the Edison Electric Company,
Wow,
right? Things. And yeah. So and so it is a challenge, David, especially in congested, densely populated areas. It's very much a challenge. And we have engineers that they specialize, and their expertise is there. We also have a lot of rural communities where, you don't want to necessarily dig up miles and miles and miles uh, for because of the cost, but there may be some benefit. Out on the West Coast, as a fire mitigation strategy, Pacific Gas and Electric has announced that they're going to be undergrounding 10,000 miles of their lines,
Wow.
Wow.
and they're looking into those exact questions, David, about how do we interface with existing infrastructure? What are the benefits of the new infrastructure? So like I said earlier, we agree that undergrounding is the future. It won't be for everything, but there's just so many resiliency benefits. We call them stacked benefits, right?
Mm.
So it used to be, well, could you put it underground because it's really ugly and I don't want to see it. So there was this aesthetic value of, maybe on Main Street at Christmas,
Yeah.
well, let's underground Main Street, because then at Christmas you're not seeing these ugly poles and wires and stuff like that. That's old school. Now we see tremendous benefit from undergrounding, and so accepting those challenges of sharing the space underground, right? Um, we're going to be accepting those challenges, and I think everybody takes a very practical understanding that there's increased benefits. So the cost, whatever the incremental cost increase is, we can much more easily see the incremental benefit increase as well. And so, yeah.
I know this is a very this is a question which is it's really spiked, but a lot of times, a lot of companies don't want to put a lot of money into engineering. They'd rather put into construction and deal with all the issues then. And when we're looking at that as well, it's a very siloed approach. Do you see DER actually getting rid of those silos and really dispersing the silos and all the different items or all the different disciplines coming to work together? The engineering, along with the distribution guys, along with the planners. Like, do you see it actually causing people to communicate and work a lot more closely together?
It really does. We have some wonderful construction partners that we work with. About half of our revenue is from design build. And so we feel very comfortable that since we designed the asset, we feel very comfortable that we can go build that asset to the specifications that we put into that design. Not that a typical construction company can't, but as you say, Ophir, handoffs, when you hand off the design and the procurement and the construction to all different parties, well, every handoff is an opportunity for miscommunication. It's an opportunity for delays. It's an opportunity for extra cost, right? And so we're big advocates of letting our clients know that we offer not only the design, but the design, procure, and construct
Yeah.
services. And we're getting a lot of clients take us up on that. They see the value in having a strategic partner like a Burns McDonnell, who is capable of not only doing the design to meet their specifications, but it's also going to be their trusted partner. We're going to be there for them time and again. We're going to stand behind our design work. We're going to stand behind our construction work, and they feel comfortable that they can whatever they paid from a pricing perspective to transfer the risk of that project is money well spent, and there's value added.
It's really amazing. I see that we're coming into an age of quality versus quantity, and when I say that, removing a lot of the low bid situation, really going for quality based selection, and that also comes to the Jones Act, I believe, in Congress, which passed the QBS Act, quality based selection for ACEC. So really, really amazing. And again, one of the biggest things I've always seen, and one of the things I've been advocating for years, is understanding and planning ahead what you're going to be dealing with and understanding your existing conditions. Uh, I've been in the I was in the SU industry for the last 20 years, the subsurface of the engineering industry, and really, it's always been my number one thing: plan ahead, understand what you're going to deal with. Intelligence is that biggest part. And there's a lot of new technologies which will provide you that information up front, even before the investigations. So really, I see all the industries, the above ground, the below ground, the electrical, the telecom, the gas, all of them working together. And I really hope that the model which you were talking about, the EPC, the engineer, procure, construct, where you actually have a partner in your design build, and you have a partner into your implementation of the project, is that model of the future. Uh, you know, it's really we've covered a lot here through and through, and I believe that is that one key takeaway: making sure that your partner is right for you, and that you actually have a proper plan, and they have the experience to take the information they have, do the intelligence, do the research of how it's going to work, what's going to happen, having those trusted partners together to help you facilitate your design, your build, and your actual implementation. Uh, you know, for me, that says it all. Cooperation, understanding, and going forward with innovation in the future.
And I think to underscore that, our engineers, our professional engineers, are not only excellent designers, but we train them also as project managers, because managing a project through planning, through design, through procurement, and as we're right now in the United States, and I believe worldwide, we're seeing that the supply chain is really struggling from a lack of resiliency, where it's from getting refrigerators and lawnmowers to getting cable and solar panels. The pandemic has really put a spotlight on how not resilient some of our processes were, including supply chain. And so our training our engineers as project managers, they understand those types of issues. They're good at reporting out cost, tracking cost, and then at the end of the day, helping our construction guys understand the design properly, and then building it to those specifications so that the client gets exactly what they paid for at the end of the day. So, yeah.
Amazing.
Yeah.
Sorry, David, I cut you off. I know I'm a zealot
just,
when it comes
I'm sitting
to
quietly and I'm learning
information.
as much as I can. That's why we're here.
Yeah.
Gary,
All right.
before we wrap up, any last tips or recommendations for upcoming engineers and project managers in the space? Things that they should be aware of, look out for, or look out from.
I think there's a couple things that I would tell young engineers, new employees. And one is, learn as much as you can from the experienced folks before they decide to retire. They're as Ophir said, we're trying to take their knowledge and put it in as many databases as we can before they leave. But at some point they'll be gone, and they're a valuable resource. For most companies, their employees are their most important resource.
Yeah.
And so I would say get a mentor, a couple people that you can really relate to and respond to, as well. Not only will you gain their knowledge, but you'll also gain the benefit of them having business savvy and some of the other experiences. I would say when you're participating on teams, participate on the most possible diverse teams you can find. You want as many different perspectives as you can get, to make sure that all of the stuff that could go wrong and all the stuff that could go right is out there on the table. And then as a team, decide what path do we want to take on this project. And you're just going to get great results if you open yourself up to new ideas, new approaches, because some folks are interested in some of the technology, so they'll bring that technology perspective. Some of the folks have different backgrounds; they're going to bring that perspective. And at the end of the day, you're really going to get all these amazing ideas that you can provide on your project, and your client's just going to be very satisfied with the results. And we kind of take pride in making sure that we have diverse teams, and that we maybe understand the value add proposition. Least cost, that's one thing. I agree, Ophir. There's least cost, but then there's least cost plus all the value added to make sure that your money is well spent. So that would be my advice for someone just entering the field or someone transitioning to our industry. Yeah.
Gary, you said it all. I reiterate. It's really an amazing thing to talk to a professional who conveys the entire envelope of due diligence and duty of care. So I appreciate what you just said, and I really appreciate the conversation that we had. David, any last words before we wrap up for today?
Great conversation, lots of great insights, and we'll make sure to tell the world about them. So, thank you so much, Gary.
Good luck to you. Yeah, good luck to you guys on your webinar program. I'm looking forward to learning from other folks that you have on as guests as well.
Sure.
So.
Gary, any recommendations for next guest?
Oh boy, well,
we want Mary.
Mary has a great list of folks that she knows. It might be interesting for you to get someone on that's maybe a senior utility manager who is really looking at it from the business side. And they can answer some of these same questions, and they'll have their perspective.
Mary, maybe we'll have another conversation afterwards.
Absolutely. Now, I know a few people that might be interested.
Okay, so we'll discuss.
All right.
Anyway.
Perfect.